This is a ramp of angle theta and an object of mass m is on the frictionless ramp, and the force, horizontal force F is applied to it that makes it go at constant velocity, constant speed up the ramp. And the mass is 50 kilogram, theta is 30 degrees. The question is, what is the magnitude of F? What is the magnitude of normal force acting on the object? So in order to do that, we consider all the forces acting on the object. One is the F, the other one is the weight, W, and the other one is the normal force acting this way. I should put that somewhere else. Normal force, mass M. All right, these are the forces. But then we draw a free body diagram. You can take this as x-axis, this as y-axis, the horizontal and vertical. If you do that, then you get this x and this y, and this is the object. Remember, we shrink the object to a point, so that it becomes simple. And then there's this F is in the x direction, and W is in the y direction. W that has magnitude mg is negative y direction, and normal force is at some angle this way. And the ramp is at this direction, and this angle between ramp and horizontal is theta. And that because the normal force is perpendicular to the ramp, it makes this angle also theta. Because if you look at these sides of this angle, this side is perpendicular to this side, and this one is perpendicular to this one. The two sides of this angle are perpendicular to two sides of this angle. That makes them the same angles, okay? So now we know that this angle is actually our theta of the ramp, and these two forces are along the axis. What to do next? We know the acceleration is 0 because this velocity is constant. Now we apply Newton's law. The sum of Fx equal to max, which is 0. Right? And sum of Fy also. Let me write that one too. Equals May, which is also 0. So these two we have to apply. And you see we have two equations and we have two unknowns. So we write each one of the components in terms of the magnitudes and then solve for the magnitudes. The first one, sum of Fx, means this Fx plus Wx plus Nx equal to 0. And then the other one says Fy plus Wy plus Ny equal to 0. That's what these two equations say. But then we write each one in terms of their magnitude. So what is Fx?
F cosine theta.
What
or
is theta?
F cosine 0.
Cosine 0. So F is in the x direction and positive x direction. So Fx becomes simply F magnitude, right? And Wx. Wx is 0. And what about Nx? Nx, you can find the standard angle, which is 90 plus theta. You can always say n times cosine of 90 plus theta. Or you can say, in terms of this angle, because the x component is not adjacent to theta, you can use sine, but it falls in the negative direction. You can say negative n magnitude times sine theta. And then equals to 0. That is this equation. The other equation says sum of the y components equals 0. Fy is 0. What is Wy? What is the y component of W in terms of magnitude? what is the y component? I'm writing this for this problem. You say that f is in x direction, fy is 0. What is the y component of w?
It's negative.
But it is in the negative direction. So negative magnitude. The magnitude of w is mg. So negative mg, right? The y component of w is negative mg. And what is the y component of normal force? Because y component is adjacent to theta. Either you say sine of 90 plus theta, or you can say cosine theta plus n cosine theta equal to 0, because the y component of n is adjacent to this theta, so it goes with cosine. And falls in the positive direction, so it's a positive n cosine equal to 0. Now we have these two equations in terms of the magnitudes, and we can solve for the for each one. You see this, you want f and n. This equation involves both of them, but this equation only involves n, so that's easy to find n. So let's find n from that equation. N cosine theta from the second equation is equal to mg. Therefore, n is equal to mg over cosine theta. Right? And then if you plug in n here, you can solve for f. F is equal to n sine theta. And then n is this, so f equals to mg over cosine theta, which was magnitude of normal force, times sine theta. Can you simplify that?
Sine theta over cosine theta is
Tan theta. So f becomes mg tan theta. So that's f. That's n. If you want to put the values that we have now, f becomes 550 times, let's say g is 10, 50 times 10 times 10 of 30 degrees. How much is that? 289 Newton. Make sure you get that right. And then the normal force is just mg divided by cosine 30. So mg 500 Newton divided by cosine of 30 degrees. So normal force is 577 Newton and F is 289 Newton. Does it make sense? You see, we do free body diagram, apply Newton's law, write the Newton's law in component form, then write each component in terms of magnitude and direction. Then you solve for magnitudes. That's what we do all the time. Okay?